Alright, so this is our clock, and we start with individual registers for the hours for both 12 and 24-hour time, the minutes and the seconds, and we break that down by their position, and then just use additional counters to correct that, and that way we don't have to convert from decimal to binary or vice versa. And then we also have registers for the current alarm setting. And basically we just have a 100 megahertz counter that counts to 100 million. And that should give a positive edge approximately once every second. And then we use that to increment the first counter, which then increments to 10, resets to 0, increments the second counter, which is the second seconds place, which will then increment to 60, and then minutes, go to 10, and then 60. And then finally, the hours will go to 12 for 12, 24 for 24. And then we do similar things for the alarm for both seconds, minutes, and hours. And then this here is just to assign the proper value for PM. So PM is enabled if the current 24 hours value is greater than 12, and this is just to complete through 20 into the 20s up to 24, and otherwise it's just blank, no indicator of PM or AM. And this is what we use to set the time for seconds rather than increment seconds. We found that it's easier just to keep it from incrementing, and then this is a better way of setting the seconds time. As well as minutes, that just increments once every second. Same with hours, and then same with the alarm values. And this is just to enable the alarm. And then finally we have a reset that basically just makes sure that all the values are synchronized and sets them all back to 0. And that's pretty much it.
So this is our clock, and it's currently showing the time, which we can switch to show the current alarm time. And as you can see, the alarm is set to 0, 0, 0, 0 and 24-hour time. So if we switch back here, we're currently at 27 seconds, and we have it just enable the alarm for the total of the minute. So we can see here that this alarm will remain enabled, this LED, all the way at the end until the time switches over to 0001, at which point the alarm is no longer active. So then as we switch to 1, I'm going to increment the alarm to 0001, which should therefore re-enable the alarm. So if we display the alarm and then press this, oh, that's the second, you want minute. And as you can see, with the alarm set to 0001 and the current time at 0001, the alarm remains enabled until we disabled it, at which point it will turn off. So we have these 3 push buttons. The first will reset the time as well. It's just really the time to 0, 0, 0, 0, and we can switch to 12-hour, and we can see it's 12, 0, 0. So we'll then use this center push button to increment either the seconds, which rather than incrementing them, this button will just hold it at a specific time. So this allows you to set it at a particular value and then release once you want it to remain active. And then if we switch to minutes using these slide buttons, we can hold this to increment the minute values, and then finally the hours. So if we stay in 12-hour mode and we increment the hours up to 12 noon, we can see this indication of PM versus AM. As you can see in 24-hour, if we go to say 3 o'clock, we're at 15:07, and then back, and this PM will remain active until midnight, at which point it will switch to AM with no indicator. And we can change the minutes and the hours simultaneously, as well as, like I said, hold the seconds, and then reset back to 12 a.m. and that's it.
So basically for our design, we decided not to include an ALU because the ALU would take up some time to do some operations, and that would lead to our clock being slower and not that accurate compared to the real-time clock. And we decided to let the user increment, like set time and set alarm with the push buttons rather than having him enter them with the switches, because it was more convenient. And we had an issue about incrementing seconds, because our increment seconds was working at the frequency of 1 second, so basically that would do nothing. So we wanted to do that at first by incrementing seconds by 2 each time, but in that case we couldn't reach odd numbers or even numbers depending on the case. So we decided to simply hold with the push buttons hold the seconds with the push buttons. That was an alternate way that was easier. And yep, that's pretty much it. And the reset button is used for to basically synchronize the 12-hour and 24-hour clock. Like, the user should press the reset before using the clock. Thank you.